Okay, so we've got to the point where we can detect if there's a tie or not. If there's not a tie, we can say, give a bit of feedback to the user saying you chose whatever it was, you chose rock, whatever, and the computer chose whatever the computer chose. So we can put that in here. So we've got an if statement saying if what the user chose was the same as what the computer chose, then we print out it's a tie. Otherwise, we'll print out system.out.println. We'll print out what everyone chose. So here we can say the computer chose and then whatever it was that the computer chose. And then also you chose and then whatever it is that the user chose. Hopefully that will work. And the up here we printed out, while we were testing, we printed out what it was that the computer had chosen. Well, let's comment that out now, because by this stage the computer has made its choice, the user has made their choice, and it doesn't matter by this stage if the user knows what it is that the computer chose, because they've already made their choice. So let's see what happens there. So we'll compile it, then we'll run it. Okay, so I'm going to choose, let's say, rock. Oh, it's echoing back what the user chose. We'll get rid of that in a minute. So it turns out the computer there chose scissors and I chose rock. Let's get rid of the bit of code that's producing that. Where is that? It's there. We don't need that anymore. Compile it. And then run it. Okay, so I'm going to choose paper. There we go, the computer chose scissors, I chose paper, so I would have lost on that occasion. Okay, so now we've got to decide who wins. This bit here, if it's a tie, we want to exit the program at that point, because if it was a tie, we don't want to then go on to bother deciding who won because it was a tie. So what we can do here is we can say return there, and that will exit this main method. Okay, the main method, it doesn't give back an integer or anything. That the return type is void, so you can just type return like that. If it was a method that returned, say, an integer, you'd have to supply an integer here, but that doesn't apply in this case. So now what we've got to do is decide who won. So now this is going to be a rather complicated nesting of if statements. There's no doubt many ways of doing all of these things, but the easiest way for us here is probably to say if the user choice equals rock, well, then inside here we've got to put a bit of code that says if the user choice is rock, I've put the quotes in the wrong place. We have to have a look at what the computer chose, they're not going to have chosen rock because they've already dealt with what happens if there's a tie. But if they've chosen paper, then the computer wins. If they've chosen scissors, then the user has won. That code will have to go in here. And then we want to say else if. Now I think what I'll do is I'll pause the recording at this point and I'll type in the rest of this if else construction and then resume in a moment and talk through what it's doing. Okay, so I've typed in the rest of this if else if construction. Here we've got if the user has chosen rock, so in between this curly bracket and that one, in other words in here, we've got to type what we want to happen if the computer has chosen, well, the computer couldn't have chosen rock because that would have been a tie and we'd have exited the method at that point. We'd have returned from the method at that point. So the computer couldn't have chosen rock, but if the computer has chosen paper and the user chose rock, then the computer's won. If the user chose scissors, if the computer chose scissors but the user has chosen rock, well then the user has won because rock beats scissors. So inside this part of the if statement, we've got to test again what the computer has chosen and respond accordingly. So again, I'm going to pause in a minute and fill in some code there and then we'll have a look at it. Okay, so this is what happens if the user has chosen rock. Then if the user hasn't done that, so they might have chosen paper, so we can go else if the user's chosen paper here, or the user's chosen scissors, or if they haven't chosen rock or paper or scissors, they must have typed in some other thing. So else, well, if we get down here, it means they haven't chosen rock or paper or scissors, so they must have just typed in something random like I did earlier. So we can say choice. Let's test if that bit works. So if I type in something that's none of the three, let's suppose I type in this, which I did before, it says unrecognised choice. Okay, you can see the computer made a sensible choice, but the user did not. Okay, so I'm going to pause. I'm going to type in the code that we need here, and then we'll discuss what's going on there. Okay, I've finished typing that bit. Now, what we've got here is that if the user has chosen rock, well, if the computer chose scissors, it means that the user won. And if the computer didn't choose scissors, we know they haven't chosen rock because that would have been a tie. The only other thing they could have chosen would be paper, which means the computer would win. And then we need to do the same thing here. So it's nesting if statements inside if statements. So it's an organizational issue here. You have to organize things carefully to make sure that you test for all the possibilities you want to test for. I'll put in the if inside here and inside here, and then we'll pick up in a moment. So here we go. I've finished the other two nested if statements. There's one here where if the user chose paper, well, if the computer chose rock, it means that the user has won, because the user's paper beats the computer's rock. If the user chose scissors, well, if the computer chose paper, the user has won, and if the only other thing would be that the computer wins. Okay, these if statements, you can nest an if inside an if as deep as you like, really. Nesting one inside another isn't too bad. If you have to nest too deep, it probably means the design's not very good, but nesting just one level is okay, I think. So let's compile that and see that it works. So we'll compile it, okay, and then we'll try playing the game. So type in your choice. I'm going to choose paper. I've won. Okay, so the computer chose rock, I chose paper, I've won. Let's try playing the game again. Right, this time I'm going to try paper again. Oh, that was a tie. The computer evidently chose paper again. Let's try again. Let me try rock this time. I've won again. I'm trying to get something to demonstrate to you that I don't always win. Let me try paper again. Ah, I've won again. Oh no, the computer won. Okay. What did I choose? I chose paper. Oh, the computer chose scissors, so the computer won. Okay. So hours of fun there. A couple of bits you might like to think about. If I were to when we test who has entered what, we're using the words rock, paper, scissors. The first letter here for rock is an uppercase R. If I were to type in, let's play it again, but let me type in rock with a lowercase r, do you see it doesn't recognise that rock with a lowercase r is the same as rock with an uppercase R, so you might like to think about how you could rectify that. The other thing, of course, you could do is you could say, do you want to play again, and then keep a record of how many wins the computer's had and how many wins the user has had, and then when they've had enough it could print out the computer won 5 times, the user won 6 times or something like that. Anyway, there we go. Hours of fun.